it's Mr. Munson here again. Hey, we're looking at Unit 2, the beginning of that, and so this unit is going to be completely on circles. And so today's lesson is just some basics about circles. Some of the stuff you probably already know, so other things are brand new. So make sure you're focused and let's get started. This is Concepts 2.1, Circle Basics. These are the things that we want to make sure that we understand. What are the special properties associated with circles? That's what the essential question is for this section. And then the outcomes is that you should be able to identify special segments and lines associated with circles. You should be able to use the relationships between tangents and radii to do different things and understand that relationship. You should be able to classify arcs as minor, major, and semicircles, and then you should be able to name an arc. Okay, so we're going to start off with some vocabulary because these things you have to have in the can. You have to understand them before we can go any further. Let's get started. Okay, here we have our starting of our vocabulary. Again, you should have a vocabulary list started and you're just adding on to it. If you don't have this list yet, you're going to have to find somebody that has already started it and has it complete, or you're going to go back to videos from Unit 1 and make sure you're getting them in there. Here we go. Circles. It's the set of all points equidistant from some given point. So, if I had some point here and I said, hey, I want to know all the points that are equidistant from that. Let's say they're 3 inches away. So here's a point that's 3 inches away, and here's another one, and here's another one, and another one. And so basically a circle is all the points that are exactly the same distance from some point. So they just kind of keep on adding up, and before you know it, we've got ourselves a circle. If you look over here to the right, this is how I would name it. I would call it circle M. I'd draw a circle, put a dot in the middle, and then write the capital letter M, because we're talking about the center point. It could be any letter here. I just happen to make this one M. It could be O, it could be P, whatever it is. But that capital letter is a point. Hey, just one of the things you want to know is that point in the center is actually not part of the circle. It's just a reference point for setting up the name of the circle and where the circle lies. The points of the circle are out here on the circle. Okay, so keep that in mind as we move forward. Okay, next up to bat is the word chord. It's a segment whose endpoints are on the circle. Okay, so as I said, these endpoints are on the circle. When we draw a connected segment, we've got ourselves a chord. This is the kind of way that we would write the name of this thing. It's a segment, so it looks like 2 capital letters with a segment barb. All right, up next is diameter. It's a chord that includes the center of the circle. So if you look, you have a red chord over in this drawing, over in this area. You have a red chord there, and you have a blue chord. That blue chord includes the center of the circle, so it's considered a diameter. Again, we would call it, it's a chord, so we call it diameter CD. Next up, let's talk about a couple of segments, some special segments, the diameter, the quarter special segments. Let's take a look at the radius segment. It's a segment with the end point on a circle and the other end point at the center. Okay, pretty straightforward. Now we have some lines that are associated with circles, and so the first one we're looking at is a secant line, a line that touches the circle twice. And so here you are. It's touching the circle twice. Okay. Hey, listen, a chord, which is a segment, is cut from a secant line. If you think about it, the blue here is a chord, but the red, which includes that secant, is a line. And so when you're talking about secants, you'll make sure that you have that little arrows on the ends of those things, and that would make it a secant line going on. All right, here we are with the next one, tangent lines. Tangent lines are lines that touch a circle only once. And so in this particular drawing, you can see that it touches right here at A. We call that a point of tangency. It makes sense to call it that. And so if we were looking at naming that tangent line, we would again call it a line with these arrows on top. And we'd say, hey, that's tangent AB. I apologize for my N there. It got kind of messed up apparently. All right, let's talk about what could be a very new concept for you, an arc. An arc is a portion of the set of points equidistant from the circle. So if you look at the blue line out here, now I'm turning it into a red, that's an arc. We label arcs using a set of letters capital letters, the points that are on the circle, and we strike an arc across it. So that would be the name of that arc right there. Now, interesting enough, we have three special kinds of arcs that we're going to look at. We're going to look at minor, major, and then semicircles. Okay, let's move on. So here you have it, a minor arc. It's an arc less than 180 degrees. Easy enough. And so if you take a look at my green line there in the drawing, that's a diameter. It includes the circle. Let's put a center point there. And so we know that in a circle, going from one all the way around creates a full circle in 360 degrees. So this particular arc, which is labeled A and B, it has to be less than 180 degrees, which would be half the circle, right? So if I was looking at half the circle, there's half a circle. And so the blue line is definitely less than that. So we have a minor arc. Two letters, we use two letters to talk about minor arcs. And so next arc that we're talking about is a major arc. So a major arc is a greater than 180 degrees. Pretty straightforward. The thing I want to point out is with major arcs, though, we are always looking at using three letters. That's very important. So if I only use two letters, suppose I was to write the letters C and D. First of all, we use two letters for minor arcs, so that's definitely not a major arc. But the arc that I could be talking about is this one right here. And so there's some confusion that can happen. So whenever we're talking about a major arc, we're going to be looking at using three letters. Don't forget that, okay? All right, semicircles. Semicircles are equal to 180 degrees. We'll also use for semicircles three letters to designate it. We'll strike an arc across the top of it. That lets the person know we're talking an arc and not a segment. So as we look at this drawing, we can come up and talk about certain names of things. For instance, we know that from our definition, this item right here, this line, is a tangent, and because it meets and touches the circle in only one place, we would call that a point of tangency, and we would label that AB with a line above it because tangent lines are lines. We could talk about secants. Here's an example of a secant right here. A secant is a line that touches the circle in two places. Okay, and so we'd call that secant GD. Now, what I want you to know is that there's times where, you might be looking at a picture and it says, hey, label a secant, and GD's not drawn in there for you. And you have to imagine that there are tons and tons of lines here that have not been drawn. So there's other secants here. So if I ask you to draw or name a secant that's in this drawing, and as this one has GD is already there, you want to label that one. But if there's one missing, then you draw your own. So here's an example of another secant. We call that line BD, and that's a secant because it touches a circle in two spots. All right, and so the point of that conversation is let you know, hey, don't be limited by what is there, especially if something's not there. You can add it. There's lines that haven't been added. However, on a test or quiz, if a secant is already given as a possible one, don't come up with a new one. Use the one that's given in the picture. About a radius. Well, here's an example of a radius. We could call it BO, right? Or OB, either way. Another radius would be O to C and O to E. Those are all radii. Can you find a chord? Remember what a chord is. Look back at your definitions if you're having trouble. But go ahead and see if you can find a chord, and then I'll strike one up. All right, so here's a chord, E to C. That's an example of a chord. How about from G to D? Now we've talked about, we've talked about G to D with a line above it, and we call it a secant. But when I put a bar above it, it's called a chord. All right, let's talk about naming arcs. So again, we have different kind of arcs. We have arcs that are minor, major, and then semicircles. So an example of a minor arc in this picture that's cut by this angle, which is from the center, right? We'll call that P. An example of a minor arc would be the arc AB. Okay, we write that as AB with a bar across it. Okay, let's come up with a major arc. Okay, so we would see the major arc, this back one, is definitely greater than 180 degrees. So how would we name that? Put me on pause, see if you can name it, and then check with your check with my writing. So I have major arc ACB. So I know by the name we're talking a major arc, something greater than 180, because there's 3 points involved in this name. I know this is a minor arc because there's only 2 points involved in the name. Now to get a semicircle, we're going to have to actually extend this radius a little bit and make it a diameter. And so once it's a diameter, then I now know that this right here is a semicircle. Well, we extended the diameter. Let's call this point D. That sounds good. And then we'll label that as a or as a semicircle. Go ahead and write down what you think the semicircle's name would be, and then we'll come back. All right, and so an example would be ACD. All right, very cool. Now there's another semicircle up there that we didn't label. Would you be able to color in and shade in the arc that is called ABD? Go ahead and shade that in. Put me on pause, and I'll scribble that in here in just a second. There I have it. That's the semicircle ABD. Let's take a second and talk about a theorem that I would like you to know as we leave this section. Theorems are basically statements that are absolutely true every single moment of the day. And so what I want you to do is create a theorem sheet, okay? And so you're just going to start adding to this theorem sheet. Now we're going to also have things called postulates, and we'll add it to this theorem sheet as well. So this very first one that I want you to put down is a theorem, and it's a radius is always perpendicular to a point of tangency. So you can see that blue dot there. That's the point of tangency. That's where the line meets the circle, point of tangency. And then we have a radius that comes down to the green line and meets at that point of tangency. This is what I know from that theorem, that forms a right angle because they're perpendicular. Lines that are perpendicular form right angles. This is going to be really useful to us. You're just going to pack this away for now. I just want you to have that information. But here's the thing. We're going to be later on building triangles and looking at that right triangle right there and getting some lengths of it. But we have to be able to refer back to this idea that the tangents and radii meet at a right angle. Okay, there you have it. There's your try it problems. And don't forget, there's a link down in the description that you're going to touch that link, and then you're going to go and answer those questions. Take care.